Hi, my name is Karina Plancart Soto, and our group project topic is Newton's Law of Universal Gravitation. This law, developed by Isaac Newton, explains how every object with mass attracts every other object with mass through the force of gravity. The strength of the gravitational force depends on the masses of the objects and the distance between them. This concept is important because it helps explain planetary motion, satellite orbits, and many other phenomena in physics and astronomy. So, for the original experimental process, scientists studied the motion of planets and objects in space to better understand gravity. Isaac Newton used observations from earlier astronomers, especially Johannes Kepler, to help develop the idea of universal gravitation. Newton compared the motion of objects on Earth, like falling apples, to the motion of the moon and planets in space. Through mathematical calculations and observation, he concluded that the same gravitational force affects all objects with mass. This led to the development of Newton's law of universal gravitation, which explains how gravitational force depends on mass and distance between objects. The motivation behind studying gravity was to better understand how objects move both on Earth and in space. Scientists wanted to explain why objects fall toward the ground and why planets remain in orbit around the sun. Isaac Newton was motivated by observations of motion and the work of earlier astronomers like Johannes Kepler. By studying patterns in planetary movement and applying mathematics, Newton aimed to discover a universal rule that could explain gravitational attraction between all objects with mass. One modern benefit of Newton's law of universal gravitation is that it allows scientists and engineers to accurately predict the motion of planets, moons, and satellites. This discovery is important for modern technology such as GPS systems, satellite communication, and space exploration. By understanding gravitational forces, scientists can calculate orbits and safely launch spacecrafts into space. Newton's work also created a foundation for later scientific discoveries in physics and astronomy, making it one of the most influential scientific theories in history. Future research related to Newton's law of universal gravitation is expected to improve our understanding of space, black holes, dark matter, and gravitational waves. Scientists continue to study gravity using advanced technologies such as space telescopes and satellites. Researchers also use modern physics theories, including Einstein's theory of relativity, to explore situations where Newton's law may have limitations. In the future, continued research on gravity could help improve space travel, satellite systems, and our understanding of how the universe was formed. Hi, my name is Karina Plancart Soto, and my portion of the project focuses on Newton's law of universal gravitation. This law explains how every object with mass attracts every other object with mass through gravity. The strength of the force depends on the masses of the objects and the distance between them. Okay, so I already went over the relevance of the question topic, so I'm going to go ahead and jump over to 4.2, which is the benefits of understanding the question. So, understanding this question is important because it helps explain how gravity changes over distance. This concept is used in astronomy, physics, engineering, satellite technology. It also helps scientists predict how planets, moons, and satellites move in space. The process of writing the question, I created this question by focusing on the inverse square relationship found in Newton's equation. I wanted to show how changing one variable, specifically distance, can greatly affect gravitational force. I also chose this question because it connects math concepts with real world scientific applications. The uniqueness of the question is unique because it demonstrates how quickly gravitational force weakens as distance increases. Even small changes in distance can create large changes in gravitational attraction, which makes this concept important in understanding motion in space. Okay, so I use this graph because it shows the distance and gravitational force between Earth and the satellite. As you can tell by the graph, um, it helps to visualize the gravitational attraction pulling the two objects toward each other. The formula that I used was the one F equals G fraction. That's the one I used because in this equation, F represents gravitational force, G is the gravitational constant, M1 and M2 are the masses of the object, R is the distance between the centers of the object. The most important part of the formula is the distance is squared in the denominator, which creates the inverse square relationship. Okay, so to solve problems using Newton's law of universal gravitation, the masses of the two objects and the distance between them must first be identified. The values are then substituted into the equation carefully using scientific notation and proper units. After calculating, the result shows the gravitational force between the objects. And you can see all of that on this side. This equation is useful because it accurately predicts how planets, moons, and satellites interact gravitationally. Scientists and engineers use this law in astronomy, satellite communication, GPS systems, and space exploration. Okay, so one interesting fact is that Isaac Newton developed this theory using mathematical calculations and observations from earlier astronomers like Johannes Kepler, like we spoke about earlier in the presentation. Newton's work later became one of the foundations of classical physics. So, I personally found this topic interesting because I have always been curious about space and how planets stay in orbit. Learning about Newton's law of universal gravitation kind of helped me better understand how gravity affects objects both on Earth and in space. I also enjoy seeing how math and physics connect to the real world technology. And it helps kind of understand a little bit more about medical imaging technologies like X-ray and CT scans work, which is what the area of expertise I kind of want to go into. So that was pretty cool. In summary, Newton's law of universal gravitation explains how all objects with mass attract each other through gravity. The strength of the force depends on the masses of the object and the distance between them. This law remains one of the most important concepts in physics and astronomy. The sources used for this project included class materials, physics textbooks, and educational resources discussing Newton's law of universal gravitation, gravitational equations, and space science concepts.